So we already looked at a few of the data types, right? So we looked at int, then we looked at double, boolean, char, right? So they have got a certain size, right? And then this is the range which is given in the description for each data type in Java. So byte is the smallest. It the size is 1 byte, and it contains the whole numbers from minus 128 to, okay, this is 127. So this is plus 127, not minus. Okay. Okay. So then there is short, which is 2 bytes. I mean, the size is 2 bytes, and then it is also contains whole numbers from this range, in this range. And then int, it is of 4 bytes, and it has got this range of this large negative to positive whole numbers, and then long. So it has got 8 bytes, and the whole numbers range is quite large. So as you can see, the size is going on increasing as you go from top to bottom, right? So first byte, then short, then int, then long, all contains whole numbers, but the range is increasing as we go down, right? And then we have got float and double. So these are fractional numbers. Float, the difference between float and double is you can store 6 to 7, up to 6 to 7 decimal digits in float, but in double you can store up to 15 decimal digits, right? Then boolean and char. Boolean is 1 bit, as you know, so it can store 0 or 1, which is true or false. And then char can contain a single character, right? So I mean, we have seen how you can assign a value to int or boolean or char or double, right? But what if in your programs you have got, say for example, you have got a char, right? But for some reason you need to convert it to int. Okay, so let's see. I mean, it is possible to convert from one data type to another in Java, but there are few ways of doing it, right? So that is called typecasting, converting a value from one data type to another. Okay. There are two types basically. If you want to remember, they have different names, but you can remember it as implicit, and the other one is explicit, right? So implicit is more automatic. So it is automatically done by the compiler. You don't need to do anything else. You just need to assign the values, and the Java compiler will convert a data type, which is a lower data type, into a higher one, right? This is also known as widening typecasting. Also, it is also known as automatic typecasting. So as I said, two data types are converted automatically, and it is mandatory that two data types are compatible. Otherwise, it won't do automatic conversion. Okay. So you have to assign a value of smaller data type to a bigger data type, right? So it depends on the size, the table which I showed you previously. So based on that, you can convert your data types. Okay, so this is a kind of smaller to larger, right? So when you convert, say for example, this example I've given, right? So int, I have assigned a value to int a, and then I'm trying to assign long b equals to a, which means the int value will be stored in this long data type, right? So, and similarly for float. Okay, since we are converting from lower data type to a higher data type, right? So it will be done automatically by the Java compiler. Okay, so any questions in this? So this is one type of typecasting in Java, which is the implicit. So the other type is the explicit conversion. As I said, it is also known as narrowing typecasting. Okay, and this is this is a situation where you want to assign a value of larger data type to a smaller one, right? And this is also known as explicit typecasting. This is used when your data types are incompatible. Okay. So, and if you see the flow, I mean, you can convert it from like double to float to long, int, short, byte, right? So from larger to shorter, right? Now, this is an example of the explicit conversion or the narrowing typecasting. So if we have a double value and then we want to convert it, right, to we want to convert it to a long. So we have to do this explicit typecasting, which means we have to give this in brackets long, right? So this should be small letters. So all these should be small letters. I will correct this, but so and similarly, if you want to convert it to int, so again explicit conversion, right? So you need to put that in brackets. So this is known as explicit conversion, where you are doing it explicitly, but if you are doing it from a smaller data type to a larger data type, then the Java would do it automatically. Okay. So this was all about typecasting. The next topic is control flows, right? So there are different control flows in Java. Till now, we have just written a simple program, right? So where there was no control flow, but we'll see how the control flows work in Java. Okay. And if you have heard about this statements like if, else, while, for loop, right? All of these are control flow statements. Okay. So what it is, a program's control flow, it is the order in which the program's code is executed. So you can control the flow of the execution based on some condition, and that is what is control flows, right? So we can use different conditions and statements in order to change the execution flow of our code. Okay. Now, as I said, there are different types of control flow statements. First is the decision-making statements, right? So we have got if, else, else if, right? There are loop statements, which is while, do while, and for. And then there are jump statements, break, and continue. Okay, so all of these are different statements through which you can control the flow of your program execution or code execution. Okay, so coming to the first one, the if-else statement, right? So this is a dice game program, right? And this is a flowchart which shows you the flow of how your execution will go, right? So if you're playing a dice game program, player will basically select a number by rolling this dice, right? And it could be anywhere between 1 to 10. Now we are putting a condition here. If number which comes up in the dice is greater than 6, then we want to print that the player won the game. If it is less than 6, then the player lost the game, right? So this is the true condition, which is winning the game, and this is the false condition, right? So there are, based on this condition, there are two outcomes, and that is how you are controlling the flow of the execution, right? So um, you are stating a condition, and then based on the result, you are then identifying which way the program should flow, right? Or the execution should flow. So if it is satisfying the condition, you want to take the execution to a certain flow. If it is not satisfying the condition, then you want to take it in a different way. Okay, so there are two flows right now. Similarly, you can create any number of flows, and you can then put a condition and then take your flow of the execution to any particular direction. Okay, so that is what I meant by the control flow execution. Okay, and if else statements, they help us to control our flow of the program execution or code execution. Okay. So this is the same thing what I told, right? So based on the condition, we will. So this condition is wrong again. I need to correct this. So this will be less than 5. So we need to print you lost the game. Okay. So saying that, let's now try to create this program here. Okay. So it's simple if else condition, but this is how you implement if else statements in Java. So I will name it dice program. Guys, if you are not, can you go on mute? There's some noise. Okay, if you don't know what I just did, right? So you can change the name of your program, right? Once you have already created it, right? So in IntelliJ IDEA, you can go to refactor and then you can click on rename. It will allow you to rename your class. Okay. So this is the dice game program, and what I'm going to do is we need to basically put a condition here, right? Based on which we'll decide whether the player has won or lost the game. Okay, so anybody knows how we kind of take input from the user, although we will learn this little later. So there is a scanner class which allows you to either take inputs or also do output to your console, right? So we need to create an object of this class. And then we have to do system.in. Right. So I'll explain this all in a later class where we will be looking at this particular scanner class, right? So for input output. And after this, so we need to store it in int, right? So int number equals to c dot next int, right? So what this basically it will do is it will take input from the user, right? So when you run this program, it is going to take an input, and here we are expecting an integer, right? Similarly, we have got the scanner object for different inputs, like so we can take string, boolean, or any other data type, right? So, but here we are expecting an integer. Okay, so this is the number, and now I'm going to use the if condition. So you have to write if and then brackets. Okay, so if number is greater than 6. Okay, and then we have to write the statements inside this if loop. So this is the format of if loop, and here I want to print. So you won the game. Okay, and then I'm going to use else. So here I can use both the things, right? So I can use else and I can print it out here that you lost the game. Okay. So you need to understand there are different ways of doing it. We have got if else, we have also got else if, right? So obviously, if the condition doesn't match, it is going to automatically go to this statement, right? So if number is not greater than 6, it will go to else condition. But if you want to specify or explicitly specify that particular condition, you can also do that. right? So you can also do it this way. But the logical way would be because since there is only one condition, right? So you can just put one if condition and then you can put else. If there are multiple conditions, there you can use else if, and then you can specify any number of more conditions. So the else condition should only be used at the last point, right? So when there are no conditions left, then you can use the else condition so that if none of the conditions match, it will go to this else part. Okay. But if you have got more number of conditions, you can keep on using the if condition. Okay, so this is the program, very simple one for the dice game program, right? Let's try and run this. So as you can see, I entered 2 and it said you lost the game because it doesn't satisfy the condition, right? Now, if since I ran this program, nothing was displayed on the console, which is kind of not good, right? Because I don't know what it is asking me to do. So there I can use another println statement and I can say enter your number, right? Now, if I run this, so now here it is expecting a number, right? So if I say 7, it will say you won the game. Okay. So simple program. Obviously, this could be modified a lot, but just wanted to show the if else condition. Okay. Okay. So let's go to the while loop now. Okay. This is another kind of control flow statement where you can control the flow of the execution based on a condition, right? But this is little different than if else condition, where you specify the condition first and then you write the statements. But here, your expression, conditional expression would be there or at the beginning, right? And then based on whether it is true, false, it will continue to execute your statement, right? So the statement which you write inside the while loop, it will continue to execute. As you can see this arrow bar, if it is true, it is again going to execute the same condition, right? So it is kind of a repetitive loop, okay? And if it is false, it will come out of the while loop. Okay, so as I said, loop executes a block of code repeatedly based on the condition which you specify. Okay, and then it is a control flow statement that allows code to be executed as long as a given condition is true. So that's the while loop, and this is the syntax, right? So while and then you specify the condition here, and then it goes on executing this particular statement until the condition is true, right? Same program can be written in a different way. So here we used the if else statement. We can also write it on a while loop. Okay, so let's see how we can do that. Okay, so I'll first accept the number from the user. So let's say enter your number and then scanner class to accept the input. And then we'll use int to store it. So int number equals to sc dot next int. Now here we'll use the while loop. Okay, so while number is greater than 6, or I can say greater than 10, right? So inside this, what I will do, I will again use if condition. So I'm saying if number is greater than 6, then I will print you won the game, else I will say you lost the game. So this is how I've written this. Now let's understand this. Right, so this is the if else condition which kinds of decide whether the player has won the game or lost the game. And then there is a outside loop, which is a while loop, which will decide whether it will even go into this if else loop or not, right? So if you enter a number which is greater than 10, right, which is kind of not valid for your scenario. So I don't want to execute this particular conditions if it is greater than 10. If it is less than 10, then go ahead and check the conditions based on which the result of the game would be decided, right? So this is how you can use multiple conditions or statements to control your flow, or you can put your logic based on these statements. Okay. So if I enter to, yeah, so it will not enter. Sorry about that. It will not enter into the logic because I put greater than 10. Also, it will go into endless loop, right? So this is not the right way of doing it, but I just wanted to show you how you can use a while loop. Okay. So it will continue until the number is less than 10. Okay. Yeah. So yeah, actually, I had another program for the while loop. So we'll look at that, right? So the best example of a while loop is your music player, right? So when you play any particular songs or any particular playlist, if you see there is a repeat button, right? Which is present in your music players, any music player you take. So that's what can act as a while loop, right? That is where you can implement the while loop. So if the repeat button is switched on, it will continue to play the same songs or the playlist once it is over, right? But if it is switched off, then it will kind go to the next playlist. Okay. So this is an example of while loop. So coming to the next one, which is a do while loop. Okay. Now it might sound similar to the while loop, but there is a little difference here. Okay. So what is the difference? It checks the condition even um, after the statements are executed. Okay. So in while loop, you are checking the condition at the first, but here you are executing the statements and then you are checking the condition. Okay. So the statements would be provided under this do, right? So whatever statements you want to write, you have to write it inside this do, and then in the while there will be the condition. Okay. So it will execute these statements, then it will check this condition. Okay. and if the condition is met, it will come out. Okay, otherwise it will execute these statements. So all statements are executed until the condition is false, and the loop terminates if it is false. Okay, so the difference is it will execute the statement at least once, even if the condition is not matching. Because the condition comes after the statements, it will execute it at least once. But that is not the case in the while loop, because if the condition doesn't match, it will not execute the statement, which we saw in our example also, right? So when I entered a number which was not greater than 10, it did not execute the statement. Okay, but that can be avoided in the do while loop. So as you can see, there are different kinds of statements, loops, and you have to use them based on your scenario. Okay, so what scenario you are trying to execute, you have to think which loop or which statements are suiting your particular situation. Based on that, you can go ahead and use it. Sometimes you can also use two loops or more than, I mean, any number of loops in your programs. But I don't think you should be using all the loops at once. I mean, I think at most you can go ahead and use two loop statements. I think that should be enough to handle any particular scenario in your programs. Okay, so the next kind of control flow statement in Java is the for loop, right? So it's wide. I mean, it's the most common one which we use on a daily basis when we are writing any programs or any particular code. Okay, so it provides us a compact way to iterate over a range of values, which will be specified by us, right? And it will continue to loop until that condition which we have satisfied, which we have specified is met. Okay, so this is the condition, sorry, syntax, right? So we have to use the for keyword, and inside the brackets, so we have to put the initialization condition, then the termination condition, and then the increment decrement. Okay, inside this you will have your statements. So the initialization expression, so this first condition, right, it initializes the loop, so which means it starts the loop, and then it is executed once the loop begins. Termination means it once it evaluates to false, it will terminate the loop. So this is the condition which will decide whether the loop will continue or it will terminate. Okay, and increment decrement. So this is basically you are incrementing or decrementing your expression. I mean your initialization value which you have put, right? So after each loop, it will either increment or decrement. So that is the way it is going to iterate over a range of values. Okay, so let's look at an example how you can implement for loop. Okay, okay, so I'll take a small example here where I will try to print a certain range of numbers based on the for loop. So let me take. Okay, so let me write the code and then I will explain you. Okay, so very simple program where I want to print numbers 1 to 10, okay, or 0 to 9 based on this condition. Okay, if I want 1 to 10, then I can start. So this is the initialization condition, right? So where you specify from what value your initialization should begin, right? So this I is just a variable. This is the data type, and this is we are assigning one to this particular variable, which is I. Okay, so this initialization condition, this specifies from where our value should start. So I'm specifying one, so it should start from one, and then the next condition is where you specify till what range you want to continue. Okay, so after this condition, this for loop will exit. Okay, so I want to continue till it is less than 10, or I can say less than equals to 10, right? So these are the conditional operators, right, which we have seen earlier. And then this is our incremental operator, right? So we are just incrementing our variable each time this loop continues, right? So the first time it will be one, the next time it will be two. Similarly, it will go on till this condition is satisfied, which is I less than equals to 10. Okay. And inside this, I will have my statements. So I have a print statement here. So I'm going to print a number, which is a number. Then I have just used a plus operator here so that this is appended into the output, right? So this is the I value, which will be printed 1 to 10. Okay. Okay, so if you see in the console, it is printing my numbers, which is 1 to 10. Okay, so this is how you can use the for loop if you want to iterate over a particular range of uh, any particular variable, I mean values, right? So it could be either some numbers, or it could be some you are trying to iterate over some characters or in a string or anything, any particular object. You can use the for loop. Okay, so this is how you use the for loop. If there are no questions, we'll continue. So there is another loop which is called the for each loop. Okay, now this is an enhanced version of the for loop in Java, and this is mostly used for collections. So what is collections? What are the what are the types of different collections? We will go over that later on. But since I was talking about loops, right? So I thought it will be better if I introduce you to this enhanced for loop, right? So as it says, it can be used to iterate to the elements of a collection or also a array, right? So when we look at a collection or array, I will show you how you can use this particular for each loop. Okay. The syntax is little different. So you will still have to write the statements inside the for loop, but inside the for brackets, right? So you need to specify the array collection which you are trying to iterate. Okay. And then there is a colon mark. And in the beginning, you need to define the data type, right? And then the element, which is nothing but a variable. Okay. So it is read like a for each element in the collection, execute this statement, and it will iterate until the last element of the collection. Okay, so that is how you read a for each loop. So data type declared in the for each loop must match the data type of the array collection that is being iterated, right? So if your collection type is of string, you cannot use a data type of int. You need to have the same data type in your element and in your collection. Otherwise, it won't work. Okay. So our last kind of control flow statement, which is the break and continue statements. Okay. Now the break statement, as the name suggests, it is used to terminate the loop and return the control to the first statement after the loop. And the syntax is pretty simple. You just need to write break, and that will kind of explicitly break your or terminate the loop, even if your condition is not satisfied, or if you are writing a for loop, right? And you have a certain range of numbers, and then you put a condition that I want to exit the loop if this particular condition matches. So you have to use this break statement to explicitly come out of the loop if you don't want to continue after a certain condition. Okay. Similarly, continue. So continue will skip the current iteration of the loop and jump to the next iteration. So if there is any situation where you think that if this particular condition occurs, I don't want to continue the iteration of my current execution, right? So current iteration, you want to just skip it and you want to jump to the next iteration. So in that case, you can use continue. So these are kind of two exit kind of statements, right? Where you are looking to exit out of the box, right? You don't want to exit based on the loops which you have written, the conditions which you have specified in your loop, but you want to use something, I mean, out of the box, right? Or out of that particular loop. You just want to either skip a particular iteration, or you just want to come out of the loop based on some condition. At that time, you can use break and continue statements. Okay, so these are um, all the statements which can be used, right, for controlling the flow of your code execution. And as I said, all of these could be used in different situations based on what kind of scenario you are currently working on. Okay. The next topic is methods in Java, or which is also known as functions. Okay. Uh, it is very important, especially for for automation frameworks, right? Or automation code. You have to always depend on these methods, because you need to create custom methods in your framework, or whenever you are writing any code. If you want to reuse your code, you need to depend on methods or functions, right? Which can be called at any point of your program, and you can easily reuse all your code using these methods. So we are going to look at these methods. Okay, so a method is just a block of code, right? Which performs a specific task. So you can convert any particular block of code into a particular method. Okay. And as I was saying, it helps us to organize the code, because if you just keep on writing your code, right? Say, for example, 1,000 lines of code, and every time you want to change anything, you have to change everywhere else, right? So if there is a particular variable which you're using, right, and you have used it um, in one class, and then you have used it in some other classes as well. So if you want to change anything, you have to change it in every class, right? Because you have written all the lines of code as it is in every class. But if you use a method, you can organize the code, because then one specific part of your code will lie inside a method, right? And if someone is coming and looking at your code, they will look at that particular method. Also, your code becomes reusable, because you are trying to define a task within a particular method, and then you're trying to reuse it in different classes, as I explained you earlier. Right. So let's take a real-time example. Okay. So this is a sample task, which is get instructions for driving a car, right? So there are different things which you want to do, different steps you need to perform in order to start a car. Okay. So the step one, you can say, is inserting the car keys. Okay. Then you need to start the engine, press the accelerator, right? And then there could be a number of other steps, right? So put the gear, put the brakes. So there are different functions in a car, which you need to perform in order to drive this particular car. Okay, now you can put all of these steps, right? The code which you have written for all these steps inside a single function, which is getting instructions for driving a car, right? So this could be a function which contains the code for all of these different steps. Now, if say for example you're writing this for one specific car type, right? Say for example you are writing it for Audi car. Now, if you want to write the same code for some other car, but it has got some additional functions, but still you have to write these common functions for the other car type, right? So what you will do, will you write the same code again, or would you prefer to just call this method which you have written already for a particular car type and then use it in a different car type? Plus, what are the additional functions? You can write it again inside the code, but for performing these functions, you can just call this method. Okay, so that is the logic behind using methods or functions in Java. You just put a block of code which can perform a specific task and make it a method which can be reused across your code. Okay, so how do you define a method in Java? So we were taking the example, right? Get instructions for driving a car, right? So this particular name could be your method name. Okay, so that could be anything. It is not system defined, it is user defined. So user is going to define this particular name of your method, right? Which is you. Now the tasks, as I said, will perform the different steps inside this method. Okay. So whatever steps you are trying to perform for a specific scenario, you have to write inside this particular method. And how do you call a method? So you just have to write the name of the method followed by parentheses, right? So this brackets. So this is a way you just call a method in Java once it is defined. Okay. Now coming to parameters. So a method, so this method, if you see, right, there are brackets here, which is empty. So this method has no parameters. It is a method which has got no parameters, but methods could have any number of parameters. Okay. So let's take an example here. Um, we want to add two numbers, right? Number 1 equals to 5 and number 2 equals to 3. Okay, and the result would be number 1 plus number 2, and we are just printing the result in the step 2. Okay, so it is going to print the output as 8. Now, can I use this same code to add different numbers, right? With the same method, if I have written this method to add two numbers and I'm writing number 1 is 5, number 2 is 3, and I'm trying to print the number, can I change these numbers? Yes, I can, but that I have to do if I'm using the same method. I have to always change these two variables, which is number 1 and number 2. I can make it 6, 4, then the output changes. But is it practical that I should always go into the method and change these variables? No, right? So that's where method parameters comes into the picture, right? So we make these number 1 and number 2, right, which are kind of two inputs to our methods. We make them as parameters. Okay, so using these parameters, we can now pass any value to these two variables. Okay, number 1 and number 2, and then we can perform this addition for any particular numbers, not only 5 and 3, but it will be independent of these values. Okay, so that is where you use parameters in your methods. Okay, so we can define different inputs for our function or method. Okay, the same thing which I explained. So it will be assigned when the method is called. Both number one and number two would be our parameters. Okay, so this is how you will call your method, right? Add 2,3, 4,5, and then in the output will be different, right? So this is how I'm calling my method, which will have two parameters. So let's try and look this. We have read a lot. Now let's try to implement this, right? So I will say add numbers. Okay, so let me show you both the scenarios. Okay, let me define a method first. So I will say public static void add numbers. Okay, so this is how you define a method. Obviously, I could have done away with all this public static void, right? Um, yeah, void you need to mention because that is a return type. So we are not returning any values from this method. So it has to be void. If you are returning any, then it will be changed to that particular data type. We'll look at return types next, but for now, if I don't mention this static, it will throw me an error, right? When I'm trying to call this method inside this public static void main, right? And why? So as you can see in the error, it is saying non-static method add numbers cannot be referenced from a static context, right? So you cannot call a non-static method inside a static method. Okay, so it has to be static. That is why I have made it static. I can make it private so that it can be accessible within this class, but I can also make it public so that if I want to call this particular method inside another class, it has to be public. Okay. Now, what I want to do here is int num1 equals to 4 and num2 equals to 6. Okay. And then I will say and result equals to num1 plus num2. And then I will just print for addition of two numbers. Okay, so this is the first scenario where I am just declaring my variables here and I'm just using them as it is and printing the value, right? Now this works for two numbers, right? Two specific numbers. If I add, it gives me the result. But as we were speaking, if I have to change this again, right, I need to change it in this particular code. Now it's practically impossible that you're trying to going inside the program and changing these values again and again, right? So, and that is why Java provides us with parameters, right? So what we'll do, we'll say int num1 and int num2. Okay, and then we can reduce our code. So we'll remove these part. And then we are just writing the logic inside the method. The input will be taken care of by the parameters. Okay. So you need to define the data type and then the variable name. Okay, num1 and num2, and this int is the data type. So you need to also make sure that the data type which you are using in your parameters and which you are using inside your logic inside your method should be same. Otherwise, you will face errors, right? Now, what I can do is I can use this method, single method, to print different numbers, right? I can use any number, just passing the number here and calling the method. So this is how you can reuse the method number of times for different data sets, right? So that's where you are using the reusability function of Java using methods with parameters. Okay. Now, if you see my output, I can directly print the addition of different numbers using the same method. So these are very important concepts, guys. So this is where the usability comes in, and this is where also you have to implement the same way in your framework when you are writing a framework which which contains a lot of reusable functions. So you have to keep all this in mind, right? All these concepts which we are currently learning in Java. Okay, so this is how you use parameters. Now coming to the method return types, which I was talking earlier. So you can return values from your methods, right? Let's take an example. Okay, so we want to multiply the output of the add method, right, with another number. So is it possible in this particular scenario where we have written a add method, but we are not returning any value, then how do you kind of use the output of this add method to perform some other operation, right? And that is where you would try to return the particular output which you are getting out of this method. Okay, so we can return the output in the method itself and then use it in another place. So that's where the return types is useful. Okay, so let's look at an same example where we will kind of return this value. Okay, so if you're not returning any value, the return type would be void, which means no return, right? And if you're returning any particular value, you need to specify the data type. Okay, so since I want to return a int data type, we have to specify it as int. If you're returning string, you will specify string. Okay, so this is our output and we want to return this, right? So once I change the data type to int, you will see compiler throws an error saying it is missing a return statement, right? So if you don't have a return statement, the compiler will throw an error. So here I need to specify return, okay? And I will simply say the result which I'm getting here, right? So this is the result which I want to return from this method. Now we need to change the code here as well, right? If you want to use this particular method, okay? So I will say int, and here I will say result equals to add numbers of 6,5, right? Now what is happening here is it is going to execute this method, but it is going to return me a value, which is the output, and that output I am storing it in another variable called result. Okay. Now this variable contains the output of this method, and now I can use it for performing some other operation, right? So for example, I just want to print something here. So I will say increment the output, right? And here I will say result is one, or let's perform this in int output equals to result plus 5. Okay, so I'm adding some number to the result which we are getting from our method. Okay, and I will say simply here output. Okay, now if I kind of run this. Okay, so the first three are our normal method calls, right? We are just calling the method and getting the output. Then the next one is also a method call, but then it is being stored inside this, right? And here we are incrementing the output, right? And yeah, as you can see, it has added 5 to our result, right? And the result is the output is now 16. So that is how you can return results from a method, and then you can continue to do kind of more things on the method, on the output of the method, right? Okay, so these are the different things which you can do with Java functions or methods. This is methods are a very important concept in Java, widely used across any Java programming or any automation framework or anything which you are trying to write any particular code. You have to fall back on defining methods and using the parameters and return types to kind of build your scenarios, right? Okay, so just another point left in Java methods, right? Which is called as built-in methods. Now, every language has got this. There are some built-in libraries which contains this methods which are already defined in the language. Okay. Similarly, Java has got many built-in methods which is kind of helpful when you're trying to program in Java, because you don't need to write these methods. You can directly call these built-in methods in your program, right? You don't need to write specific things which is already defined by Java inside its library. Okay, and this is the this is the default library provided by Java. So you don't need to even import any particular library. This is the default library which is present in your whenever you are creating a Java program. Okay. So built-in methods can be used by just calling them, as I told you earlier. Now we have been using a built-in method for all the code which we have written till now, if you have noticed. So system.out.println, right? So this is a built-in method which directly builds your whatever value you're passing inside the system.out.println. It prints it to the console, right? So we are not writing any code for this system.out.println. We are just calling this method and we are just passing the values, right? The underlying logic is taken care by the built-in method, which is written by Java, which is already present in Java. So similarly, you will find lots of different built-in methods which are present already in Java and which you can directly use. Okay. So you have to use the dot operator to get access to many built-in methods. And this dot is basically so the system, which is the first statement, right? So this is a class. Okay. And then you will use the dot method to go to those methods, right? So out method, then println method. So this is how you use. There are other built-in methods which I will tell you when we learn about strings, right? So there are different string methods which are built-in methods, and throughout this Java, whenever we are learning Java, we'll see a lot of different built-in methods.